Okay, here's a question with a thermochemical equation, and it's actually in three parts. I've got parts A and B written down. I'll rewrite part C here in just a second, but let's go through it. There's three independent questions based on the same reaction. So how much heat is produced when 15.4 grams of P4 react? And so it's asking you to calculate the amount of heat that's produced. Now you're given 15.4 grams of P4 and you need to calculate that heat. So that means we need to go from grams of P4 to kilojoules. Now, step by step, that means grams of P4 to moles of P4 and then use the thermochemical information to get kilojoules. All right, let's put it together. 15.4 grams of P4 divided by the molar mass of P4 times the stoichiometric information from the thermochemical equation that says 1 mole of P4 reacted produces 1774.0 kilojoules. So let's put that in the calculator and we get 221 kilojoules of energy produced. Okay, how many grams of chlorine must be used in order to produce 2044 kilojoules of heat? So in this case, I'm given the amount of energy produced and I'm asked for the mass of chlorine. So that means I need to go from kilojoules to mass. So step by step, that's kilojoules to mole of chlorine and from mole of chlorine to grams of chlorine. So it's essentially going backwards from the spot we did before. So let's put it together. 2044 kilojoules times, now let's take a look at the stoichiometric information in the thermochemical equation. It's not 1 mole for chlorine, it's 10 moles for chlorine. So 1774.0 kilojoules per 10 moles of chlorine. So remember that thermochemical information that's given is based on the stoichiometry of the balanced chemical equation. So in this case, it's 10 moles of chlorine. So you've got 10 moles of chlorine times the molar mass of chlorine, and you get 817.0 grams of chlorine reacted in order to get 2044 kilojoules of energy. All right, so the next part of the question, I'll have to write that down. It says that 450.0 kilojoules is produced. What mass of phosphorus pentachloride is produced, is formed? So what am I given? I'm given 450.0 kilojoules. I'm asked for the mass of PCl5. And so the plan in this case is to go from energy to mass of product. And so I need to go from kilojoules to moles of product, PCl5, and moles of product to mass of PCl5. Let's check on the stoichiometry. It's 4 moles of PCl5. So that means 450.0 kilojoules divided by 1,774.0 kilojoules for every 4 mole of PCl5. And then I multiply that by the molar mass of PCl5, 208.21 grams PCl5. And I get, as a final answer, 211.3 grams of PCl5. And that is all 3 parts of that problem.